All right, so a little bit of change of pace. Let's take a look at how we might graph using factored form. So how can you use factoring to graph the function f of x equals x squared minus 2x minus 8? So we're going to write out a few steps on this so that you have something to look back on in your notes. First thing we're going to do is factor the related equation. And the reason why we say related equation is because right now it's a function, f of x equals this. So what the related equation is if we replace the f of x with 0 equals x squared minus 2x minus 8, and now we have a related quadratic equation that we can solve. So we're going to factor this. Let's take a look. Our x squared does not have a number with it, it's just x squared, so we can find factors of negative 8 that add up to negative 2. Those factors are going to be a negative 4 and positive 2. So we're just going to write x minus 4 times x plus 2. Zero product property lets us set each factor equal to 0. So x minus 4 equals 0, x plus 2 equals 0. You guys you probably have already started solving these in your head. I've been showing all the steps, but once I have my equations equal to 0 written, we can say x equals 4 and negative 2. You can picture how we would solve those. So what we want to remember is that when we solve a quadratic equation for x, how that relates to a graph is we just found the x-intercepts. So next we're going to plot those x-intercepts. We know that x is a positive 4, so we'll plot the point at positive 4. And x is also a negative 2, so we plot the point at negative 2. Our next step is going to be our axis of symmetry. Now what we want to remember about the axis of symmetry is that it is the line that splits your parabola in half. So if you have your two x-intercepts, one at negative 2, one at positive 4, we know that the axis of symmetry will be halfway in between those 2 points. So if we go ahead and count, 1, 2, 3, 4, 5, 6, cut that in half, 3 units in from either side is where your axis of symmetry will be. We can see that's at an x equals 1. So let's go ahead and draw in our axis of symmetry at x equals 1. We can see that looks pretty good as far as being right down the middle of where that parabola will be with those two x-intercepts. All right, x equals 1, axis of symmetry. Step 3 is going to be to find the vertex. So let's remember, if you know the axis of symmetry, you know half of your vertex. So we already know the x value of our vertex. So all we're going to do is plug that into the original equation. We're going to plug a 1 in for all of the x's. So we have 1 squared minus 2 times 1 minus 8. Plug that into your calculator exactly as we wrote it with the parentheses, and we get a negative 9. So then we go back to our graph and we can plot our vertex at 1, negative 9. We can see that the graph will head up toward those x-intercepts from the vertex, so that's looking pretty good. Our a value was a positive 1. This parabola we're drawing is going to open up, so everything's matching. Our fourth step is going to be our graphing pattern. So we look, our a value is a positive 1, so we have our 1, 3, 5 pattern. And now we can go back to our vertex and graph our pattern. From the vertex, you go up 1 over 1, up 3 over 1. When we go up 5 over 1, we're actually hitting that x-intercept. So that won't happen every time, but everything's working out nicely. We can feel good about our parabola. We can reflect those points on the left side or just do the pattern going up 1 but to the left, up 3 to the left, up 5 to the left. Go ahead and draw in. Hopefully you guys draw a little bit better than me, but there is our parabola. All right, so we're going to try another one. This time our function is f of x equals 2x squared plus 5x minus 3. So we're going to follow the same steps we did before. First step, we're going to factor the related equation. Replace your f of x with 0, so we have 0 equals 2x squared plus 5x minus 3. Now, take a look at this x squared. We've got a 2 in front. We can't factor it out of all 3 terms, so we have to do our factor by grouping method. We're going to take the 2 times the negative 3. We get a negative 6. We need factors of negative 6 that add up to a positive 5. When we have to add up to a positive number, remember our larger factors will have the same sign, positive, so I'm going to make the smaller factors negative. And now we're looking for the pair that adds up to 5, and that is a negative 1 and 6. So now we rewrite our expression. We're going to replace the 5x with a negative 1x and a positive 6x. The 2x squared and the minus 3 come down. And now we do our grouping. Group the first 2 terms, find a GCF. They have an x in common, so we're going to factor an x out of both terms. When we factor the x out of 2x squared, you're left with just a 2x. Minus 1 when you factor an x out of the 1x. Group the second 2 terms. Our GCF here is a positive 3. So let's factor a positive 3 out of both terms. Leaves us with a 2x minus 1. How do those parentheses look? They match, so 2x minus 1 goes in our first parenthesis, and the x plus 3 goes in the second set. Remember, this is equal to 0. We are going to solve this factored form. We have factored form now. We set each factor equal to 0 and solve. So first we take our 2x minus 1, set it equal to 0. Let's go ahead and solve this one. Add 1 to both sides. Remember that 2 in front of the x, we can predict a fraction or decimal, so x equals a positive 1/2. Then we take our second factor, x plus 3, and we set that equal to 0. Solve for x by subtracting 3 from both sides, and our second value for x is a negative 3. So those are our 2 x-intercepts. So we go back to our graph, and we can plot those right on the x-axis. Positive 1/2 and negative 3. All right, step 2. We're going to find the axis of symmetry. So if we look back at our graph, we'll notice that because of that 1/2, it's a little tricky to figure out exactly where halfway between is. It's not as easy to count in to find a halfway mark. So we can find what's halfway between 1/2 and a negative 3 mathematically. If we just take the 2 numbers, 1/2 as 0.5, add the second number plus negative 3 and just divide by 2, that will tell us what value is halfway between those two. So 0.5 plus negative 3 is negative 2.5. Divide by 2, we get a negative 1.25. So our axis of symmetry is x equals negative 1.25. We're going to draw that in, and it'll be, as best as we can do. It's a 0.25, so we'll just estimate where that is. It's hard to get super exact on a graph. So here we have a negative 1, and then about a quarter of the way further than that, our axis of symmetry of x equals negative 1.25. All right, step 3, find our vertex. So again, we know half of our vertex is negative 1.25. So all we do is we take that, we plug it into our function for all of the x's, and that will give us the y coordinate of our vertex. So we type that into our calculator with all of those parentheses and everything. Don't forget the squared button. And when we do that, we're going to get a negative 6.125. So again, kind of a tricky vertex to plot. So we'll just do our best. We know it's going to be on the axis of symmetry at a negative 6 and then just beyond the negative 6, so just a little bit below, like barely below, is where this vertex will be. All right, we're going to finish this up with step 4, our graphing pattern. So we look at our function to find the a value. Our a value is equal to 2. So we take 2 times the 135, and our graphing pattern is going to be a 2, 6, 10 pattern. So we'll just do as best we can, sketching where this is. It's not going to be super exact, but from our vertex, we're going to go up 2 units. I'm still just a little bit below and over 1 from where that line is, and that puts us right about here. Then from that point, we'll go up 6, and over 1 gets us right there. And then up 10 over 1 is off of our graph. But it's all lining up. We can see, it might not be super perfect because these were some tricky points to plot, but all of those points on the right side work out. So now let's get the points on the left. We'll go up 2 to the left 1, up 6 to the left 1. That puts us right there. And we will draw on our graph. Whew. Man, sorry for the long video, guys, but there's a lot of good math in that one.